This topic is on reducing the radicals. We're going to focus just on essentially the square roots, but I'll introduce some of the other ones. This vocabulary slide, you don't need to write it down. I just want to introduce ourselves to this again. This is our radical sign. What's underneath the radical sign is called the radicand. And then what's out in front, here's the index. Here are the perfects chart that you should memorize in this course. So I would recommend you pause right now and start writing them down. What the perfect squares are: 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So you want to make sure you know your perfect squares. There are perfect cubes that you should know. Some things like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, and so on. Our perfect fourths that we should know: 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16, and so on. So I'll go ahead and scroll through here just so you can see the other perfects chart. What we're going to do is 3 examples on the slide. This is probably a review for you. And we're going to focus on reducing perfects in the square root of 25, square root of 36, square root of 16. Now, yes, you probably can do this on your own without these extra steps that I'm going to show you, but it's going to lead into our next slide. So the first one, the square root of 25. There isn't an index showing, so I'm just going to put a number 2 there. And I'm going to break down the square root of 25. And notice that the 25 is a perfect with 5. 5 times 5, or 5 squared, is 25. So 5 squared is 25. Our index is 2. If our index and our power match up, then they undo each other. So we're left with just this number of 5. So we say the square root of 25 is 5. Let's do the second example. The index is 2. It says it's a square root of 36. So our index is 2. We can break down 36 as 6 times 6, or 6 squared. Well, our index and our power match up. Here's our index. Here's our power. So we're left with is 6. So we say the square root of 36 is 6. Maybe you want to try example C on your own first. The index is 2. We say that's square root of 16. So you can break down 16 as 4 times 4, or 4 squared. Index and power match up, so we get an answer of 4. The square root of 16 is 4. All of these are perfects. This second example slide is where when they're not perfects. We want to reduce them down and break them down. So we have the square root of 32. Our index is 2. So we want to break down 32 into product of 2 numbers. So we say 32 can be rewritten as maybe 8 times 4. Or it can be written as 16 times 2. There are many ways to multiply 2 numbers to get us to 32. I just did a couple of them here. The one that we're going to work with is the second one. Notice that 16 is a perfect with 4. So we can break down that 16 as 4 squared. And then we still have that 2 left. And now the square root of 4 squared is 4. Because my index and my power match up, so I'm left with a 4 out in front, and then what stays underneath is this number 2, because that's not raised to the second power. So our final answer then is 4 square roots of 2. Example B, our index is 2. It's a square root. So we want to break down 8 into a product of 2 numbers, something like 4 times 2. And then you can break down 4 as 2 squared. Now my index power match up, so this 2 can come out in front. Then I still have this other 2 that stays underneath. Last example in this video, square root of 20. Try it on your own if you want. Index is 2. We say the square root of 20. A couple ways to write 20. 10 times 2. 4 times 5. 4 times 5 would be the better choice. Now rewrite 4. 4 is the same thing as 2 squared. Then you have a 5 left over. Index and power match up, so this 2 comes out in front, and then the 5 is left underneath as a radical.